All right, so here are our notes about the Voronoi diagram. So hopefully you already have a pretty good idea about how to make a Voronoi diagram. So here is my velociraptor, here's my toxic waste, and here's my dragon. And from our warm-up, we were trying to keep as far away as we could from all three of these things while walking through the middle of them. So sometimes this is known as the toxic waste dump problem, where you're trying to figure out if these are your three towns and you need to put a toxic waste dump in here, where would be the most equitable place to put it so that it's the farthest away from all three towns. So this is kind of a little bit of a misnomer, because if you do want to try and put a toxic waste dump somewhere, you wouldn't put it in between the three towns. You would put it like way over here. So kind of a funny name for this problem, toxic waste dump problem, because who is going to put a toxic waste dump between three cities if they have somewhere over here that would be a lot better to use? So more often this is used to locate, say, the next Starbucks. So you've got three high schools. You want to try and get as many students as you can from those three high schools. So where should you put the new Starbucks? Okay, stuff like that is more what Voronoi diagrams are used for. They're also used for weather stations. If you are on your cell phone and you're trying to figure out what is the local weather, your cell phone is going to figure out where you are, and they're going to take cell phone data from the closest station near you. So Voronoi diagrams are used in a lot of different applications, but oftentimes in business, they're used to help you figure out where's the best place to put a new business. Okay, so V, T, and D, the velociraptor, the toxic waste, and the dragon are called sites. Okay, so these things are called sites. That is an important word. The boundaries between the cells, so we're going to actually create this in a little bit, but the boundaries, those are going to be the lines that we're going to create to separate the sites. So the boundaries between cells, and the cells, when you saw in Desmos, those were the different colored areas. So again, that's a good word for us, are formed by the perpendicular bisectors of the segments between sites. So what we figured out in Desmos is that if we connect one site to the other, and then we find the midpoint, we're going to draw a line perpendicular through that midpoint, and that's going to form the boundaries. So the boundaries are the perpendicular bisectors of the segments between sites. So we're going to write down step by step how you would actually do that. But these are the three important words for our Voronoi diagrams. Sites are the existing places. Boundaries are the lines you're going to draw on that are going to create the cells, which is the area around the sites. Okay, so here's the step-by-step instructions. So step one, find the midpoints between each pair of sites. So for example, between V and D. Notice I didn't put any numbers on here. So you could use the midpoint formula, which is in the formula packet if you have numbers, but we don't have numbers. So we are just going to look at vertically, how far is it, and horizontally, how far is it? And we're going to take half those distances. So we're going to actually create this after we write down the directions, but let's write down the directions first. So we're going to find the midpoints between each pair of sites. So we're going to have a midpoint between V and D, D and T, and V and T. Second step, find the slope of the line between each pair of sites. So we're going to figure out what's the slope from V to D, and what's the slope from T to D, and what's the slope from V to T, because in the next step, we are going to use the perpendicular slope. So we're going to find the slope that connects the two sites, but then we're going to actually find the perpendicular slope and use that along with the midpoint to write or draw the equation of the boundary line between each pair of sites. Okay, so that's going to actually get us the boundary line. So if we can find the slope from V to D, we're going to take the perpendicular slope, so which is the negative reciprocal, and that's going to be the slope of the boundary line. Okay, the boundary line is going to be perpendicular, and it's going to go through the midpoint. So we can use that perpendicular slope and the midpoint to actually draw, or write rather, the equation of the line, or draw the line on the grid. Okay. Then we need to know, well, where are these boundary lines going to stop? Because if I have a boundary between T and U, it's definitely not going to go like this and run over the velociraptor. Instead, there's going to be a boundary line between V and D, and it's going to run into that boundary line between D and T, which is going to run into the boundary line between V and T. See, that's going to create our boundary lines. Okay, so those are our boundary lines, and we're going to actually do this in just a second, and they are perpendicular bisectors of the segments that connect the sites. Okay, then, well, that point there in the middle where my three pens came together, that's called the vertex. So to get the intersection of the boundary lines, they intersect at the vertex. We are going to find the intersection of the equations, okay? Find the intersections of the boundary lines to find the vertex between cells. So again, if I put these on here, if I put on my perpendicular bisectors of those segments, it's going to form a vertex. Oops, can't see what I'm looking at. It's going to form a vertex. So how can we get that? We're looking for where these lines are crossing each other. So we can do that on our graphing calculator. We can enter the equations into our graphing calculator, or in this case, we're just going to do it visually. Okay, so you can do it very precisely with your graphing calculator. That especially is useful if the dimensions here are ugly numbers. And but that's the basic step. So you can kind of eyeball. Okay, I'm not sure why my video stopped right in the middle. I kept talking and the video stopped recording. So I actually made the Voronoi diagram, but now I'm going to do it again. All right, so we are starting with V, T, and D. So when I set this up, I gave myself some nice dimensions here. I had some nice even numbers. So T is going to be horizontally 8 units away. 1, 2, 3, 4, 5, 6, 7, 8. There's the toxic waste dump. And then the dragon is going to be 2 over and 6 down. 1, 2, 3, 4, 6. I made it nice and easy for us to do this without having weird fractions and all that. Okay, so I am going to start making my boundaries by first finding the midpoint between two of my sites. So between V and T, it's 8 units, so that means the midpoint is going to be 4 units over. So there's my midpoint. Okay, I can also do the midpoint between T and D. So it's 6 down and 2 over. So half of 6 would be 3. And then it was 2 over, but half of 2 would be 1. So there's the midpoint. So all the way down was 6. So the midpoint's going to be down 3. From T to D, the horizontal distance was 2. So halfway is going to be 1. So down 3 over 1. And you can see visually that it's also the midpoint. And then between V and D, I need the midpoint there. So it's 1, 2, 3, 4, 5, 6 down. So that means I'm only going to take half of that, which is 3. And then it's 1, 2, 3, 4, 5, 6 over. Half of 6 again would be 3. So down 3 over 3. So I'm doing half of the vertical distance and half of the horizontal distance. So there are my midpoints. Okay, that was step 1. So if we look back at what we had to do, find the midpoints between each pair of sides. Oh, I realized what I forgot to, what also got cut off on the notes before is if you actually have coordinates for these points, here's the midpoint formula you can use to get the midpoint between 2 points. Again, if you have coordinates, you can use the slope formula to get the slope between a pair of sites. And if you are writing the equation of the boundary lines, you can use y equals mx plus b, where you get your m from here, and you get your x and your y from the midpoint. And then, of course, you have to solve for b, figure out what that y-intercept would be. But for the example that I'm doing right now, I'm just going to be doing it straight on the graph paper. I'm not going to actually write any equations, just so we get a feel for the Voronoi diagram. But we can definitely use all of our equations, all of our formulas to find the equations of the boundary lines if we had our picture on a coordinate grid. But I don't have it on a coordinate grid. I just have it on graph paper with no numbers, but that's fine. We can still do it. Okay, so step 2 is to find the slope of the line between each pair of sites. And then I'm gonna go ahead and sketch in the perpendicular bisector. Okay, so we just did V to D. That was down 6 over 6. 6 divided by 6 is 1, and it's going down, so that's -1. So from V to D, it has a slope of -1. So the perpendicular slope would be +1, and it's going to go through the midpoint. So I'm going to have a boundary line that's going to go like this. So I'm going to grab myself a straight edge. I like to use Post-its because they're nice and small, and I don't know where my student ID is or my teacher ID. Okay, so this one is going to be like that. And I'm not going all the way across. I'm just going to get kind of a general idea where they are, and then I'll extend them until they knock into each other. Okay, V to T. This one's actually super easy because it's 8 units across. There's my midpoint. This has a slope of 0. The perpendicular slope is going to be undefined. It's going to be vertical. So I can go ahead and I'm going to put some dots on where that would be. And now I can actually see where these two boundaries are going to intersect. Isn't that convenient? So I can go ahead and put that in. Those are now intersecting. And so now I can do the third one. So this has a slope from D to T. It has a slope of +3, up 3/1, up 3/1. So the perpendicular slope would be -1/3. So -1/3, that would be down 1/3. Or I could go up 1 and to the left 3. Oh, and look at that. There it is. It is running into the other two, intersecting the other two boundary lines. So there we have it. See how fast and easy that can be. That's because I did have nice even numbers, nothing too difficult. And maybe this wasn't the greatest straight edge. I did not do a great job of connecting those points. I should probably put my glasses on too. That would help. There we go. That's a little bit better. All right. So what have we got here? We have boundary lines. Here, I'm going to do the big reveal because I actually did this before, so I'm just going to go back. So what have we got? We've got our sites, our V, T, and D. Those are our sites. The boundaries in between them are also can be called edges, so the edges. And then the regions around the sites are called cells. So here's the cell, the cell, the cell. So I was mentioning before about data on your cell phone. Like if you want to know what the temperature is, there's going to be different temperature stations around your area. And if you are in, say, this orange region, you're going to get information from this particular data gathering location. And that's the temperature that's going to be sent to your phone. But as soon as you cross this boundary, then all of a sudden this data center is going to be closer. And then so you're going to be receiving your data from here. So these Voronoi diagrams indicate where your data is going to be coming from. Okay, and now I got to stop my video because I'm being interrupted. Bye.